everybody. My name is Dr. Vivek Koncherry. I'm the CEO of Graphene Space Habitat. In this talk, I want to talk to you about how we are using space technology to store hydrogen for farming sectors. So just to give a brief background, as you know, the global population is growing, which means we need lots and lots of food. And the thing is, farming sector needs lots of energy, and we know for a fact that we need to move away from fossil fuels. So if you want to move away from fossil fuels, you got two choices: either battery or hydrogen. The problem of battery, you need several tons of battery to run a tractor. So, and the end of life of a battery, what happens is a big challenge. So we need a permanent solution. And in our case, we thought, let's go for hydrogen. The reason of hydrogen is one of the most abundant chemical element in the universe. It's said to be about 75% of the mass of our universe is hydrogen. But there are challenges with hydrogen. Hydrogen is so small, it leaks through the material. And if you use a metal to store hydrogen, there is a problem called embrittlement. It goes into the metal and the metal becomes brittle. But if you use a polymer to hold hydrogen, the issue is hydrogen is so small, it leaks through. And that's where a new material which we were working in space can change can solve that problem. Just an example, like we are using a material called graphene. I don't know if you know much about graphene. Graphene is a single layer of graphite. That single layer of graphite is 200 times stronger than steel. It's one of the best electric conductor. It's one of the best heat conductor. A pristine graphene, even hydrogen won't pass through. And that's what we are doing here. So briefly, I will tell you why we are showing a space habitat and talking about hydrogen storage. Space station we are building is a pressure vessel, and one of the things about space station is it's always under extreme conditions. There is like temperatures are above 127 degrees Celsius on one side, back is minus 170. Micrometeorites hit the structures at 8 kilometers a second. So the thing is, our farming sector needs something. If it works in space, it definitely works under extreme farming conditions as well. It can withstand an impact of 8 kilometers a second. So that's what we are using this. The space technology for hydrogen storage tanks on Earth, and that are leak-proof, impact-proof materials. Briefly show you where I am currently based. I have a team of about 20 people. We are based at the Graphene Engineering Innovation Center at the University of Manchester. This center is exclusively focused on commercializing graphene products, and that is where we are a tier 1 partner of this center. And we have a team of scientists developing the pressure vessels for hydrogen storage tanks. And one thing is, sometimes when you think of science, people think it's boring. But the thing is, in our team, we do it for fun. We play with the graphene, we play with space station, we play with hydrogen. So it's about the fun that drives us. It's not just the sustainability is important, but people need to have fun in their work. But then it's no more work; it's mostly fun. And just to show you this hydrogen storage tank machine, we developed a machine that can manufacture the hydrogen storage tank. The problem we faced early on was there was no machine available in the market that can coat graphene and make a pressure vessel. So we decided to build it bottom up. This is a picture of a machine we developed, and of course we like fun, so we decided to copy a Star Trek theme. So the whole machine looks like something from a Star Trek. So we spent a lot of time making it look cool. Currently we are working on like a command center. If you ask a problem, we have a team of scientists. They will come back to you with a solution within hours, rather than the traditional way of days, weeks, or years to solve a big challenge. Because, to be honest, pretty much all the problems we are facing on Earth, there are solutions, but nobody followed it through. So we are a team of people. We believe in collaboration as well. One company cannot make any big changes, but a collaboration with different farmers, different companies, different research centers, together we can make a change, not just by one company. But this is just to we are a private company. We are not an R&D facility, so there are private investors who invested quite a lot from North America into us. So private companies want revenue. I mean, sustainability is important, but it need to make financial people also need to be happy. Otherwise, it's a big problem. We need to depend on grants. So in our company, we are focusing on three. Short term, we are making lightweight oxygen storage tanks for medical sectors. It's much lighter. And of course, medium, currently we are working on hydrogen storage systems mainly for farming. I want to tell you why we choose farming. I mean, first we decided to go to aerospace, then realized aerospace is highly regulated. We can't bring anything to aerospace within 5 years or something. It is going to take 5-10 years to put anything in aerospace. But if you go road, in automotive also, it's quite difficult. There are a lot of regulations, especially for a startup, it's really impossible. So this gives farming community an opportunity. Off-road vehicles are less regulated than automotive or aerospace, and then we decided to focus on the farming sector to make. But it needs the full support of the farming community. We need to make it economically viable, otherwise farming community won't adopt it. So that's where we decided to study what's out there in the whole world. In some parts of the world, hydrogen is quite well established, not probably in the UK. So what can we bring from other parts of the world to the UK, as well as how can we use advanced materials to make the next generation hydrogen storage tanks? And I'll pass it to my colleague Anthony, who can briefly tell you about the market and stuff.
Thanks, Vivek. So I work with Vivek and his team. I'm a project manager, and I just wanted to talk to you a bit about the commercial aspects of what we're doing and why we're doing it. So as you can see up there, they've put my fact up for me, but the world's population is set to grow by over 2 billion by 2050, and to satisfy the food production needs, it's going to have to increase by 70% in that time. It also, the population growth is set to forecast to grow predominantly in developing countries, and in those developing countries, we're looking at nearly food production needing to double by 2050 to meet those demands. So when we look at then the emissions that we have and the carbon footprint currently, it's around 17% annually of emissions that relate to agricultural activities, and within that 17%, we have around 1.5% that relates to actually the fuel emissions, whether it's diesel or other carbon fuel that each year. So to tackle that, we wanted to look and think about what our solution might be. You're probably wondering what I'm now holding. This is actually a prototype. It's a Type 5 pressure vessel to hold hydrogen that's developed in the lab, and this is part of our solution basically, because what we're looking at is the development of an end-to-end supply chain for hydrogen from it's the storage, it's the supply, it's the whole management and the ecosystem that we're looking to develop. As Vivek said, we've chosen to start with the agricultural sector because there's some of the regulatory reasons, but also we feel it's an addressable market that is also quite keen to adopt. If you think about some of the benefits aside from the sustainability issue, we all know at the moment that there's issues around fuel security and securing the supply chain. There's also the cost. We've seen the cost of energy rising and things like that. And there's also the point about being potentially an early adopter. We know that there's legislative changes coming in around sustainability and things like that. So this is just a way to help drive some of that. So we also want to look at the kind of, I suppose, this collaborative angle and how we can do this together, because as Vivek said, it's not just one of us, and we know that we're quite a small part in this. But if we can team together with government, farmers, suppliers, ultimately buyers as well, then we feel that we can make a difference and really implement something here. And I think, just in conclusion, that if we can deliver a sustainable product to the agricultural sector, then we're benefiting people and the planet. So that's really what we wanted to say.
Am I on? Good. Well, thank you very much both to Anthony and Vivek there for a really interesting presentation. As the editor of Farmers Weekly, farming's biggest trade magazine, I'm well aware of how many different types of cutting-edge science is interacting with farmers on an annual basis. But, you know, there's many farmers in the industry who feel that's part of our image problem, that we're seen as very traditional, and it's just brilliant to have the support of a sector like yours to be able to take the next steps into the future. Is there any questions on graphene or hydrogen then? Yes, sir.
Hello. So that's a hydrogen storage device.
Yes.
I was going to ask, thank you very much.
Yeah.
Presumably, in space, this would power a fuel, what's it called?
Propulsion.
A propulsion system, exactly.
Yeah.
Okay, and I'm not familiar with the compressibility of hydrogen, but I suspect you're going to get a high PSI on this?
Absolutely. I mean, there's two types of hydrogen propulsion system. I mean, one is you can store it as a gas or you can store it as a liquid. In the gas, normally there's already cars in the market from Toyota. They're storing about 700 bars. It's a gas form that this one can hold 700 bars, but you can store double that energy if it's liquid hydrogen. But liquid hydrogen is highly reactive at room temperature. You need to keep it about minus 250 degrees Celsius. So you need a cryogenic storage tank. And for cryogenics actually means the one you have is a single wall tank. If it's a double wall, then it can be a cryogenic. The reason of double wall is vacuum is the best insulator. You don't want to lose the the temperature. So you can have two walls, and in between it could be vacuum, or there is a material called aerogel. This is one of the lightest and the best insulating materials. So we are working on a prototype cryogenic storage tank as well. But cryogenic system can store double that of a gas system. But the problem is in a car, ideally gas is better. But if it is a tractor or if it's an aeroplane, liquid is better because there are systems to keep that hydrogen cool. But in this tractor, it can well accommodate. The one behind, it's a giant one. That one need liquid hydrogen storage tanks because it consumes lots of energy and you don't want to run out of that. Thank you.
Any other questions? Could you just describe a little bit more, perhaps, gentlemen, where we are now? I think there's a few prototype hydrogen tractors on the ground. So tell me about what are the next steps as you see it.
Yeah. So I would say there are few tractors in the market, but the issue is that supply chain. Even if you make a tractor, the farmers, which may not be close to a city, need that supply of hydrogen. So we need to solve that supply chain issue. And there may be several hundreds of kilometers from a major city. How do you get that hydrogen to them in a cost-effective manner? That is a challenge that needs solving. In fact, I would say at least 10 years ago, there were tractors that were fitting hydrogen. But once they make a vessel, where do they get the hydrogen from? So that's where we are opening some facilities globally because we want to solve that supply chain issue to customer because our farmers. First thing, cost is extremely important to farming industry, and we want to get to them at the best cost-effective way. I think that's the barrier at the minute.
So that is simply why, if you think about the race between electric and hydrogen, that's why electric is winning at the moment then, because the national grid exists.
Yeah, electric is winning because currently the way hydrogen is produced, there are few different ways. One is called like a gray hydrogen, then there's blue, and there is green. The gray is the most economical way to produce gas, but is then dependent on the fossil fuels. So then what's the benefit of it? There's a question. Green is ideal, but the green cost is still high. There are people working to bring the green hydrogen cost down. It's coming, and that's one issue. Also, there are storage challenges. Hydrogen leaks through the material, so the efficiency could drop. So these are the challenges we are addressing at the minute.
And I think JCB are one of the manufacturers that are making a bet on hydrogen. Is there any other sort of companies in that supply chain you want to give a shout out to here?
Yeah, I mean, I talked to different tractor companies, and they pretty much all of them have at some point worked on hydrogen. But when I talked to them, I told them I will solve the supply chain because we have a storage and transport system, and that's what they pretty much all the tractor companies are extremely interested to work with us. We are not just telling, oh, we will help you, and they said, oh, we already got one, but we will help a farmer. We may not be helping a tractor company, but we said we help a farmer to get the hydrogen to the farmer.
Fantastic. Well, we wish you all the best with cracking the many problems on the road ahead. Finding solutions, that's the best way to put it, isn't it? Okay. Thank you both. Thank you, Vivek, and thank you, Anthony, for your time this morning. Really appreciate it.
Thank you very much, everybody. Thank you.